Welcome back to the Algebra 2 series. And today we're looking at a continued video. So the first half we started with properties of logarithms, and now we're working into the second half of this video where we're going to do some practice examples using the properties of logarithms to either write um, several logarithms as a single logarithm or to take a single logarithm and break it down into several others. So let's take a look at this example here. We see that there's a 2 that's out front. We see that these two are being subtracted, and the nice part is we've got the same base right here, base 3. So let's work this out. I want to turn this into one logarithm, and my goal is to have, in the end, log base 3 of box. We want to have some big ugly in the middle there and not worry about anything else. We want to just kind of have log base 3. So the first thing we want to do is take this 2, which we learned becomes a power inside. So that becomes log base 3 of x squared minus log base 3 of y. And that helps us out because now once we have that, we can use the subtraction property with logarithms as long as they're the same base to bring them together here. Log base 3 of x squared divided by y. Now if you put a parentheses around that, I'm perfectly happy with it. You don't have to, but that's fine. So it looks just like this. And we've combined all this into one logarithm. X squared over y is the term we're looking for. Now these things can go by pretty quickly, but other ones have some twists to them. For example, here we see this nasty double negative, minus minus, and then of course the 2 that's located here, which we'll have to deal with right away. One of the things that I like to do is, in a problem like this one, is to take the natural log of x. That one's fine. But in the second part, if you don't mind, I'll do two things at once. I'm going to take this 2 and bring it up here as a power. But the second thing I'm going to do is I'm going to factor the negative out of both of these terms to give me natural log of x minus 1 plus the natural log of x plus 1. And don't forget, I brought that 2 up as a power. So notice what I've done here is I've taken this subtraction of two different parts. I've got a subtraction here and I've got a subtraction here. I took both of these negatives and factored them out as a common term so that I could have a positive in the middle or a plus or addition situation. That helps me because now I can write these as a product. If you recall, this one right here is going to be the natural log of m plus the natural log of n. And we know that that combines to the natural log of m times n. And that's what I'm trying to accomplish in that parentheses area there. So this becomes the natural log of, and I'll put it in a bracket, x minus 1 times x plus 1 quantity squared. That's a big old parentheses around that whole thing. So I have some unneeded parentheses here because now once I've got that established, I'll take the parentheses out. This is the natural log of x minus the natural log of this whole wonderful monster here, x minus 1 times x plus 1 squared. And I'm not going to do anything with that. I'll just leave it alone. But because I'm subtracting right here, I'm going to bring these together as a single logarithm, and it's going to be a fraction. The x is in the top. The x minus 1 times the x plus 1 squared is in the denominator. And in this case, I'm just going to stop right there. There's nothing else I need to do with that. Woo, that was a tricky one. All right, that's how you bring that all together. And one of the things that happens if you don't do this fancy work here is that you get some sign errors within the problem. You want to try to prevent that. All right, next we want to do the same thing, except this time we're going to take these apart. Rather than put them together, we're going to try to bring this thing down into the simplest components. So we want to have things like this. A log base 5 of something m, and then plus or minus some b log base 5 of some other thing n, or whatever. We want to bring this apart into several different pieces. Essentially what we're doing is we're getting an answer that looks like the beginning of the last problem. So here we have log base 5. Um, the way that I might interpret this right away is to write log base 5 of x minus 1 over x squared all to the half power, because I know that that half, which is the same as the square root, will come outside. If I do that, I'm going to get half log base 5 of x minus 1 over x squared. That's ugly. Okay, there we go. So that is a good start. And of course, this reminds me of log base b of m over n, the property that allows us to break this apart into log base b of m minus log base b of n. Doing that, I'm going to leave this half here, but this time I'm going to put a little parentheses around my answer. It'll be log base 5 of x minus 1 minus log base 5 of x squared. That's looking good. I obviously would like to combine these, so I'm going to bring the 1/2 in there, giving me 1/2 log base 5 of x minus 1. Now this first part cannot be broken down any further. The second part, 1/2 log base 5 of x squared. This one, you'll notice the 2 can also come out front here and will cancel with that half. So the final solution here, 1/2 log base 5 of x minus 1 minus log base 5 of x. And that's it. Box that and run. You don't want to go any further than that one. All right, so that's the next step to working out these sums or differences. So I'm trying to get the sum or difference from a single logarithm. Let's see if I can put the whole thing there. There you go. All right, and the final example is very similar to that one, except this time it's in base e, or the natural log. And of course, we've got a lot of stuff to handle here. The first thing I suppose I would do is break that apart rather than factoring things down right away. But I can factor them down eventually. So in the first step, I'm going to break it apart as the natural log of x minus 1 squared minus the natural log of x squared minus 2x minus 15. All seems to be going quite swimmingly so far. Bring the 2 out front, so that's going to be 2 times the natural log of x minus 1. Don't forget, that's stuck. You can't do anything with that one. Minus. I see. We have a little bit of a factorization here. I think, well, at least I'm hoping that it factors, and it does. That's x minus 5 times x plus 2, which represents a product for us. That's the m times the n, and we know that a logarithm that has an m times an n can be broken up. So I'm going to break that up into its sum. I'm going to put a parenthesis around this again. It's going to be the natural log of x minus 5 plus the natural log of x plus 2. And just like we did in the last problem, we'd like to distribute this negative into both terms. That's the trick to this one. We want to make sure we do that properly. So the final answer here, 2 times the natural log of x minus 1 minus the natural log of x minus 5 minus the natural log of x plus 2, excuse me. And we have now broken this down into its smallest components. That takes care of business on those 4 examples, and that's pretty much what we're going to try to practice so that we become somewhat fluent at breaking these down and also putting them together. Good luck!